Today we are going to fill in those coordinate points in the parentheses that we wrote around the unit circle in our last unit circle video. So if you will get your unit circle note-taking sheet, pause the video for a second, find that sheet, and then we'll get started. Okay, the first thing I want you to notice is that the bottom of that sheet there are two triangles, one of which is shaped like this. If you'll find that triangle and write 45 degrees on each of these angles. So if you remember from geometry, when these two angles are the same, that means my triangle is isosceles. This side and this side are going to be the same as each other. This side is going to be larger because it's the hypotenuse, and the hypotenuse is always the largest side. So what we're going to do is we are going to create some ratios that will work for any triangle, any 45, 45, 90 triangle, because remember, similar triangles, the side lengths are in proportion to one another. So if we want to say that these two sides are the same, their ratio would be 1 to 1. So we're just going to call those both 1. And then you remember from the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. 1 squared plus 1 squared, that's 1 plus 1, which is 2. And so that one, this side, is going to be the square root of 2. The square root of 2 squared would be 2, right? And leg squared plus leg squared is hypotenuse squared. 1 squared plus 1 squared equals the square root of 2 squared. Okay, write that on your 45, 45, 90 triangle. All right, this next part, I don't want you to write down. I just want you to watch. Do you remember when we talked about the unit circle, we said that the radius of the unit circle has to be 1. That's why it's called the unit circle, is because the radius is 1. And when we put the triangle inside the unit circle, the hypotenuse of our triangle was the radius of the circle. So I want to have a triangle. In order to write things on the unit circle, I want to have a triangle with the hypotenuse of 1. So I'm going to take my triangle that I have here. This is the one I'm going to memorize. Don't write this part down. This is the one I need you to write down. This is the one I need you to memorize. But I need to adjust it. I need to scale it so that the radius of the unit circle is the hypotenuse, and that's going to equal 1. So what can I do? What can I do with this square root of 2 to make it equal to 1? Well, I can divide it by the square root of 2. And remember, the ratios of the sides have to be the same. So if I divide one of them by the square root of 2, I have to divide all of them by the square root of 2. So on the hypotenuse here, square root of 2 over square root of 2, that equals 1. Everything is good. 1 over the square root of 2. Do you remember from before that we don't leave square roots in the denominator of a fraction? So I'm going to need to rationalize this. I'm going to multiply by square root of 2 over square root of 2, which we have practiced before. In the numerator, 1 times the square root of 2. That's the square root of 2. All right, and then in the denominator, square root of 2 times square root of 2. Well, those are the same. Remember, square root of 2 times square root of 2 is 2. So when I scale my triangle, this side is square root of 2 over 2, and this side up here is 1 over the square root of 2 as well. So the scaled side here is going to be the square root of 2 over 2. Okay, so this is the triangle we're going to use inside of our unit circle. The one with the 1 and the 1 and the square root of 2, that original one we wrote right here, that's the one that we are going to use when we're working our problems. Okay, let's do the same thing with this one. I'm going to create some side lengths that will be proportional for any 30, 60, 90 triangle. So find this one, put 30 in the smaller angle and 60 in the larger angle. And you can see that the side across from the 30-degree angle is the smallest, so I'm going to call that 1. It turns out in a 30, 60, 90 triangle that the length of this side is half the length of this side. So that means this side is going to be 2, because 1 is half of 2. And then just like before, I'm going to use the Pythagorean theorem to find this side. 1 squared plus something squared equals 2 squared. So 1 plus something equals 4 if I square those. So that something is the square root of 3. 1 squared is 1. Square root of 3 squared is 3. And when I add those together, I get 4, which is 2 squared. So that follows the Pythagorean theorem. Okay, now this one is a little bit trickier. When I go to put this one inside the unit circle, I have to kind of lay it on its side because I need the hypotenuse to be the radius of the unit circle. Just like before, my hypotenuse is going to be 1. Oops. My hypotenuse is going to be 1. So if I take this side and I scale it, so that I get 1. 2 divided by 2 is 1. Well, if I scale the hypotenuse, I have to scale the legs as well. So I need to divide everything by 2. This time I don't have anything that I need to change. Everything has integers in the denominator, so it's fine. So across from the 30, I'm going to put 1/2. And across from the 60, I'm going to put square root of 3 over 2. Okay, now just like before, I do not want you to write this one on your paper. I want you to write this original one. So you should have 1, 2, and square root of 3 written on your paper. That's the one we're going to use when we're solving problems. This is the one we're going to use to put some information in our unit circle. Okay, so here's what you have on your paper, and you have all those angle measures written on the inside. I erased them so I would have room to write, but you have all those angle measures written on the inside. Okay, find the colored pencil that you used to do the quadrantal angles. Remember, those are the ones that divide the quadrants into pieces. So let's find that color. And I'm going to do the coordinates of those points. Well, it turns out because I know that the radius of the unit circle is 1, those turn out to be the easiest ones to do. So if I know the radius is 1, then this point right here is 1 unit from the origin on the x-axis and 0 units on the y-axis because it doesn't move up, right? If I were going to graph this on a regular xy plane on regular graph paper, 1, 0 would mean go over 1 and then go up none, which is where I am right here. All right, this one is exactly the opposite. This one, I went up 1 and I went over none. So that means my x value is 0, my y value is 1. If I move over to this one, you can see that I went to the left, so I went to a -1, 0. And when I come down here, I went down, so the x value is 0, the y value is -1. Okay, so that's all I need for those. I'll explain what those numbers mean in just a second. It's easier if you see that with a triangle. For right now, just make sure you've got those 4 points filled in. Okay, now find whatever color you used to do this one. You do not have to draw this triangle inside of here. I'm just going to put it inside of there to help us make sense of what's going on. Okay, you remember the one that we scaled. We said that this side is 1 because it's on the, let's make that the same color. That side is 1 because it's the hypotenuse, and the hypotenuse of the triangle is the radius of the circle. And then when we scaled it, the side that was across from 30 is 1/2, and the side that was next to 30 is square root of 3 over 2. Okay, so look at where this point is. If I were going to graph this point on regular graph paper, do you see that I would go over this much and then I would go up this much? So I'm going over square root of 3 over 2, and then I'm going up 1/2. So that means the coordinates of this point are square root of 3 over 2 and 1/2. Okay, now think about if I took this triangle and I flipped it over into this quadrant, right? This is quadrant 1. You remember that from before. I'm flip it over into quadrant 2. And if I were to draw it right here, do you see that the distances would be the same? This distance is the same as this distance, and this distance is the same as this distance. The only difference is this time I'm going to the left instead of to the right. Well, when I go to the left, my x value becomes negative. So I've got negative square root of 3 over 2, and my y value stays positive. My y value is positive 1/2. Okay, so let's move that same triangle now into the third quadrant. Let's move down here. There's my right triangle. All right, so this distance is the same as this distance, and this distance right here is the same as this distance right here. So then if I want to get to this point, I'm going to go left and down. Well, left means negative, and down also means negative. So I've got negative square root of 3 over 2 and negative 1/2. All right, let's move into the fourth quadrant. Last triangle we need to draw, and we're going to put it right underneath this one. And you can see it's a mirror image. The square root of 3 over 2 side is the same. The 1/2 side, I just went down. So that means the x value is back to being positive, and the y value is negative. So in the fourth quadrant, I have a negative y and a positive x. In the first quadrant, both of them are positive. In the second quadrant, I have a negative x and a positive y. And in the third quadrant, I have a negative x and a negative y. Okay, remember what we said in the last video about the sine and cosine and tangent and when they were positive and when they were negative? That matches with what we have here. We can see that I have positive, positive, all of them are positive here. In the second quadrant, we said that cosine was going to be negative and sine was going to be positive. Okay, so let's go back and look at our original triangle for 30, 60, 90. Let me put it back like it was at the beginning. If I were to do the cosine of 30, you remember cosine is adjacent over hypotenuse. Cosine is square root of 3 over 2. So cosine, if I look at my circle here, cosine is in the x position. Always cosine is x, and you can see that cosine is positive in the first, negative in the second, negative in the third, and positive in the fourth. All right, the same thing is going to be true with my other triangles. So look at what happens if I put a 45, 45, 90 in there. Look, I went over this distance and up this distance. So find this color, and the sides that we had written there, that was square root of 2 over 2. And so was this one because they were the same. There's my hypotenuse, which is the radius. So that means I've got square root of 2 over 2 as both my x and my y. Here's the cosine of 45. Here's the sine of 45. Well, then if I move into the second quadrant, you remember in the second quadrant, sine was positive. We wrote that up at the top, but cosine was negative. So I have that. In the third quadrant, tangent was positive, and that means that both cosine and sine were negative. And then when we move into the fourth quadrant, well, in the fourth quadrant, cosine was positive, so that means that the x value is positive, and sine was negative, so the y value is negative. But you can see those side lengths stay the same. It's just the direction that they went that changed. So sometimes positive, sometimes negative, depending on where you are. All right, let's look at our 60-degree triangle. So in our 60-degree triangle, we had the 1/2 side here and the square root of 3 over 2 side here. So that tells me that the cosine of 60 is 1/2 and the sine of 60 is square root of 3 over 2 because cosine goes with x and sine goes with y. And here in the first quadrant, they're both positive. So moving into the second quadrant, cosine is going to be negative, sine is going to be positive. All right, in the third quadrant, tangent was positive, which tells me that both sine and cosine are negative. And then in the fourth quadrant, I remember that cosine is positive, but that means that sine is negative. Okay, so if you missed any of those, here they all are typed out. Pause the video, grab the correct colors, and fill in all of those values around the unit circle. All right, and what we're going to work on tomorrow in class is being able to answer questions about those using the values that you have. So for example, what if I asked you for the sine of 45? Well, 45, sine is opposite over hypotenuse, 1 over the square root of 2, which we just rationalized a second ago to be square root of 2 over 2. And I know that 45 is in the first quadrant. Here's 45. So my sine is going to be positive. But what if I ask you, instead of the sine of 45, what if I ask you for the sine of 315? Okay, so think about what we did, 315 degrees. That's 45 degrees away from 360. So that means I went 315 degrees this way. I didn't quite make it to 360. I ended here, 45 degrees away from 360. And sine in the fourth quadrant is negative. So it's still the square root of 2 over 2. It's still opposite over hypotenuse, and then I rationalize. It's just that because I'm below the x-axis, because I'm down here in the fourth quadrant, sine, which goes with y, is going to be negative.